Hi, welcome to my video on the second derivative, d squared y and d dx squared. Second derivative, and this is video number 3. Express d squared y and dx squared, which is the second derivative, as a rational expression. I should have ION in terms of x and or y. So a rational expression, which means I need a fraction. So we have the equation of 4x squared plus 9y squared equals 36. So the first derivative is d dx, so we do the first derivative and we get an 8x, and 9y squared, 9 times 2 is 18y, and it's a dy dx, and this derivative of 36, the constant, is 0. So let's solve this for 8 dy dx, which is the first derivative. Dy dx is equal to negative 8x when you move the 8x over to the right. And now we have dy dx is equal to negative 8x divided by 18y. So that means that dy dx is equal to, divided by 2, 2 is a factor, so we get a negative 4x over 9y. So that's the first derivative, which is dy dx. Now we'll do the second derivative on this one. So the second derivative, so I'm just going to write that down, d dx on dy dx equals d dx on negative 4x over 9y. So this gives us d squared y and dx squared. And the derivative here, we have a quotient, so we do the derivative of negative 4x, I do. Derivative of negative 4x is negative 4 times 9y, subtract negative 4x, and the derivative of 9y is 9 dy dx, all over the denominator, which is 9y being squared. And so we have d squared y dx is equal to, and I don't know why I put it right there, I could have put it right here, it's all the same, so I'll squeeze it in here, negative 36y plus 36x dy dx over 81y squared. Now we want the second derivative in terms, I forgot the square here. We want the second derivative in terms of x and or y. Right here we got a dy dx, so that means that d squared y dx squared, and I'll put it on this line now, is make it simpler. So dy dx is negative 4x over 9y over 81y squared. So we have d squared y over dx squared. Again, I'll repeat, we have to replace the first derivative, dy dx, with negative 4x over 9y. Now notice that we have this expression is all x's and y's. So to simplify this, we can make it a negative 36y, and 9 goes into 36 4 times, so 4x times negative 4x is negative 16x squared over y, and that's 81y squared. So notice we have a complex fraction, fractions within fractions, but I want to eliminate this fraction. Denominator, normally we look for the LCD, but what I want to do is eliminate this fraction right here. So what I'm going to do is go d squared y dx squared. So I'm going to multiply by y. Multiplying by y, this fraction, this becomes negative 16x squared. So I multiply each part of this expression by y. So y times negative 36y is negative 36y squared. Y times this fraction, the y cancel, and I get a negative 16x squared. And y times 81y squared is 81y cubed. So that's one expression, but we can also continue if we want. That's one name, but if we want to continue, we can. I'll just show you a trick that they do. We can have two names. Make this negative 16x squared minus 36y squared, 81y cubed. I put it in descending order to have the x's first, similar to this right here, x squared and y squared. So we have, I take a negative 4 out of this, and that becomes 4x squared plus 9y squared all over 81y cubed. And so that gives us negative 4. So 4x squared plus 9y squared is 36. So that's a 36 over 81y cubed. And we can simplify this. 9 into 36 goes 4. 9 into 81 goes 9. So this becomes a negative 16 over 9y cubed. So really, if we want to, the second derivative could be this expression here, or it could be this expression here. Either one. And we don't know, but I just showed you. But I'm going to show you that. Let's take a point. Let's take this equation right here, which is an ellipse, and let x be 0. So if I take this equation and put 0 in here, that means 9y squared equals 36. Y squared is equal to 4. So that means y can be plus or minus 2. So let's take 2. Even though I'm going to have plus or minus 2, let's take the point 0, 2. I'm going to use this point, which makes this equation true, to show you that this expression here is the same as this one. So let's look at d squared y dy squared equals negative 36. I could take this one, don't make any difference. 36x squared minus 36y squared over 81y cubed. So if I take this expression and I sub in 0 for x and 2 for y, so I'm going to put 0 for x and 2 for y. 0 for x and 2 for y. So 0 for x has gone in, y is 2, y is 2. And we simplify this expression. So 0 squared is 0, so that's a 0, so that's gone. This is, and I could expand these out, but I'm not going to expand them out. We have a negative 36, so I'm just going to write that here to make it, I know you can see it, but just, I didn't have to, I could have done it there, but just to make it a little bit clearer. 2 squared is 4, and 2 cubed is 8, so if I cancel these, I get a 2 on the bottom. I have a 9, as in 36 is 4, and 9 into 81 is 9, so this becomes a negative, I got a 2, cancels here, 2 and 4 goes 2. So I have a negative 2 over 9. So the second derivative value is a negative 2 over 9 at this point. So what about the second derivative? You have d squared y over dx squared is equal to this expression. So now at this point, x is 0, y is 2. So we have no x, so y is 2. So we put 2 in. And we simplify it. We get negative 16 over, negative 16 over, I almost wrote it down wrong, 9. I left off the 9 when I looked over here. Negative 16, 9 y cubed. There it is. And I put the 9 in. So now I get, this is 9, and this is an 8. So 8 cancels into negative 16, negative 2 times. So that becomes negative 2 over 9. So the expressions, you could have the second derivative equal to this expression or equal to this expression. You will get the same value for the second derivative at any point on the curve, because the two expressions are, I won't say equal to each other, but they work out. I won't say they're equivalent, because how could you say that this is equal to this, but this is equal to this based on what we have right here, equal to the 36. So the two expressions come out to give you the same value for the second derivative. So that brings us to the end of this video, and if you like the video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and content. That's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.